Hello, my name is Donna Deering, and today I'll be talking to you about exploring graphs and algorithms. First, there's some terminology we must discuss. A graph is a representation of vertices or nodes used in math where edges are connected to some of the pairs of the nodes. Nodes are points in the graph that represent data elements, and there's connections or relationships between two nodes that we call edges. There are several types of graphs we will discuss in detail. Directed graphs have edges that go from one vertex to another like a one-way street. They're used to design word games like Scrabble or apps based on biology and genetics. Undirected graphs are like two-way street, where the edges don't have a direction. For example, like a pedestrian path where any two intersections can go in both directions, as you can see in the illustration. Weighted graphs represent edges with values such as distances between two vertices it's connected to. The illustration gives an example of the distance from one city to another in an airline route. Cyclic graphs have cycles where the nodes end where they start, without passing through any other nodes twice. These graphs are used in circuit designs, network analysis, genetic sequencing, and compiler optimization to remove redundant code when detected. And finally, acyclic graphs that don't contain any cycles. It doesn't have any repeated vertices except for the starting and the ending vertices. These graphs are used in data processing, data flow programming, and in compilers, just to name a few. Graphs are useful in apps such as social networks between users, transportation network, such as connections between cities for the airline industry, as we discussed earlier. They are also useful in computer networks, analyzing items in recommendation systems, and in web page ranking algorithms by Google. Graphs have transversal algorithms that explore all the vertices of a graph, level by level, called breadth first search, or BFS for short. It starts from a source node, then goes to its direct neighbor first before it moves to explore the nodes next to its neighbors. It uses a queue data structure to know which nodes have been visited. Then there's depth first search, or DFS, where a graph transversal algorithm explores deep into a branch of nodes, or as far as possible before backtracking. DFS uses a stack data structure to track all the nodes to be visited. Edgar W. Dijkstra was a computer science that conceived what's called the Dijkstra's shortest path algorithm, from one source node to all the other nodes in a weighted graph, such as the routing between two cities for airlines that we discussed previously. It's used as a priority queue to select the nodes with the minimum distance at each step, suitable for graphs with non-negative edge weights. Navigation systems, for example, and network routing is where it's widely used. He came up with this shortest path back in 1956, but it wasn't published until 1959. In summary, graphs are very powerful and useful data structures with diverse applications. Both BFS and DFS are graph algorithms for transversal and searches. Plus, with Dijkstra's shortest path discovery in weighted graphs, it's an essential algorithm. Here's a list of references used in this presentation for you to explore. Thank you so much for your time today.